Find the area of the curve r is equal to a sin 3 theta. Here the equation is of the form r is equal to f of theta. So to find the area we have the equation a is equal to 1 by 2 into integral theta 1 to theta 2 r square d theta. So first we have to find the symmetry of this curve. Before that, welcome back to my channel Speak with Math. And if we change the signs of r and theta in this equation, that is r is equal to a sin 3 theta. If we change r to minus r and theta to minus theta, a sin minus 3 theta, that is sin of minus theta is minus sin theta. So here minus a sin 3 theta. So this becomes r is equal to a sin 3 theta itself. So if we change the signs of r and theta, the equation has no change. So the given curve is symmetrical about the line theta is equal to pi by 2. Symmetric about the line theta is equal to pi by 2. That is, the equation remains unchanged with the change of signs of r and theta together. The curve is symmetrical about the line theta is equal to pi by 2. If we change the signs of r and theta together, the equation has no change. So the curve is symmetrical about the line theta is equal to pi by 2. Now, if r is equal to 0, this implies a sin 3 theta is equal to 0 or 3 theta is equal to n pi. This implies theta is equal to n pi by 3. When r is equal to 0, value of theta is n pi by 3, where n is an integer. And in particular, r is equal to 0 for theta is equal to 0. That is, n is equal to 0, value of theta is 0. And theta is equal to, when n equal to 1, theta is pi by 3. So r is equal to 0 for theta is equal to 0 and theta is equal to pi by 3. That is, value of r starting from here when theta is equal to 0 and back to 0 when theta is equal to pi by 3. So we have one loop in the first quadrant where the value of theta varies from 0 to pi by 3. So in between theta is equal to 0 and theta is equal to pi by 3, we have one loop. By the symmetry of the curve about the line theta is equal to pi by 2, we have one more loop in between theta equal to 2 pi by 3 and theta is equal to pi. So one loop in between theta is equal to 0 and theta is equal to pi by 3, and second loop in between theta is equal to 2 pi by 3 and theta is equal to pi. Using the symmetry about the line theta is equal to pi by 2. Using the symmetry about the line theta is equal to pi by 2. Similar loop here also. And for the value of theta between theta is equal to pi by 3 and theta is equal to 2 pi by 3. In between theta is equal to pi by 3 and theta is equal to 2 pi by 3. What is 3 theta? Here 3 theta is pi and here 3 theta is 2 pi. That is in between pi and 2 pi. That is third and fourth quadrant. Here R is a sin 3 theta. When theta is equal to pi by 3, value of R is what? R is 0. When theta is equal to pi by 3, here sin 3 pi by 3, that is sin pi, R is 0, and theta is equal to 2 pi by 3, then also R is 0. For theta is equal to 2 pi by 3 and for theta is equal to pi by 3. That is, for the values of theta between theta is equal to pi by 3 and theta equal to 2 pi by 3, sign values are negative. Sign values are negative for theta equal to pi by 3 and theta equal to 2 pi by 3. Since here we have sin 3 theta. So 3 theta means pi and 2 pi for the corresponding theta values. So this is in third and fourth quadrant, sign values are negative. So the value of R is equal to a sin 3 theta is also negative. Sign values are negative means the value of R equal to a sin 3 theta corresponding to these theta are negative. Since R is a directed distance, the points corresponding to theta between theta equal to pi by 3 and theta equal to 2 pi by 3 lies in the third and fourth quadrant. Theta corresponding to pi by 3 and 2 pi by 3. In between theta equal to pi by 3 and 2 pi by 3, 3 theta is pi and 2 pi. So in between these theta values, sign value are negative. So R is also negative and this lies in the third and fourth quadrant. Here sign values are negative. So here we have one more loop. Here the R values are negative. In between theta equal to pi by 3 and 2 pi by 3 we have one more loop. That is the third loop. In particular, when theta is equal to pi by 2, value of R is what? A sin 3 pi by 2. That is minus A. When theta is equal to R theta. When theta is equal to pi by 2, value of R is minus A when theta is equal to pi by 2. And since also R is equal to 0 for theta is equal to pi by 3 and theta is equal to 2 pi by 3. So theta is equal to pi by 3 and 2 pi by 3, value of R is 0. So the curve returns to the same point and hence a loop lies in between theta equal to pi by 3 and theta is equal to 2 pi by 3. Here the value of R is 0 and here it is minus A and returns back to 0 when theta equal to 2 pi by 3. So here we have third loop in between theta is equal to pi by 3 and theta equal to 2 pi by 3 and which lies below the initial line. This is the initial line and this third loop lies below the initial line. Hence we have total 3 loops. So if we find the area of one loop, we can find out the area of 3 loops. So in the first quadrant, we are finding the area of this loop into 3 gives you the complete area of the curve. Here area A equal to 1 by 2 into integral theta varies from 0 to pi by 3. For the first loop in the first quadrant, theta varies from 0 to pi by 3 r square d theta, or we can write it as 1 by 2 into 2 times integral theta equal to 0 to pi by 6. This is pi by 6. So 2 into integral theta from 0 to pi by 6 gives you the area of this complete loop. I am just changing the integration from 0 to pi by 3 to 0 to pi by 6 into 2 gives you the complete area. Into r square d theta is a square sin square 3 theta d theta. So 1 by 2 into 2 will cancel each other. So a square into integral 0 to pi by 6 sin square 3 theta is 1 plus cos 6 theta by 2 into d theta. Sin square theta is 1 plus cos 2 theta by 2. Here we have 3 theta. So cos 2 into 3 theta is cos 6 theta. So a square by 2 into integral 1 d theta is theta plus integral cos 6 theta d theta is sin 6 theta divided by 6, and limits varying from 0 to pi by 6. If we apply the upper limit, we get a square by 2 into pi by 6 plus sin 6 pi by 6 by 6 minus 0 minus sin 0. So this is equal to a square by 2 into pi by 6. This term becomes 0. This term also becomes 0. Sin n pi is 0. So the area of one loop is pi a square by 12. So to get the complete area of one loop is pi a square by 12 units square. Then the area of curve R is equal to a sin 3 theta have 3 loops. So 3 into pi a square by 12, that is pi a square by 4 units square. This is the complete area, pi a square by 4. Thank you.